Hello, this is Maysie Calzone from Maysie's Algebra Initiative, and today we are going over the Unit 10 topics of Algebra 1. These consist of, as you can tell by it being written 4 times in many different colors, of quadratics. We're just going to learn a ton about quadratics, all about how solving, graphing, the whole 9 yards. So let's get started. First off, what is a quadratic? Well, by definition, a quadratic is a polynomial with its highest power being 2. Which in this case it is, but the ones we're going to work with, it usually takes the form of x squared plus bx plus c. A and x are just coefficients, and c is a constant. So examples at the bottom, as you can tell, is 3x squared minus x plus 2, and 4x squared plus 3x plus 9. Okay, solving quadratics by taking a square root. Okay, so first off, we make sure our first step is to make sure the leading coefficient is 1. The leading coefficient is the number that goes in front of the term with the highest power, and in quadratics, that's the squared. So the number that comes in front of the squared x is our leading coefficient. And since there's nothing there, we know it's 1. Now, our second step is to find a pair of numbers that, first, equal the last number, or the constant, by multiplying the two numbers together. But it also has to equal the middle coefficient by adding them together. So you just select random numbers. So my constant is -6. So I got to find two numbers that when multiplied together equal -6. So I tried -1 and 6. -1 times 6 is equal to -6. It's good. It passes on that front. But it also has to be, those two numbers, when added, have to equal the middle number here, or the second coefficient, and that's 5. So 6 plus -1 is 5, so we're good. So our pair is going to be -1 and 6. And if you didn't pick a pair that worked the first time for both of them, you keep picking pairs till you find it. So our set is -1 and 6. So I take those two numbers and I make two binomials out of them by either adding or by adding them both to 6. And we all know anything plus a negative number is basically subtracting it. So x minus 1 and x plus 6 are my two terms. Now I set them both equal to 0 and I solve. So I add -1 to both, I add 1 to both sides here, which cancel out that there, so I get x equals 1. Same thing down here, I subtract 6 to cancel it on this side of the equation to move it to this side of the equation, so I get x equals -6. Okay, so now to check this and to make sure my values are correct, I plug each term back into the original equation. So I have my original equation, x squared plus 5x minus 6 equals 0, and my terms are 1 and -6. So I'm going to start with 1. So I plug in 1 wherever there's an x, and I simplify it down. 1 squared is 1, 5 times 1 is 1, and then the -6 just remains the same. So I end up with 6 minus 6, which is equal to 0, so 0 equals 0. That one works. Now let's move on to the -6 term. So I have, okay, so I just rewrote a little bit of the work, so now the work is correct. So I have -6 squared equals 36 plus 5 times -6, that's a -30, so 36 plus -30 is a +6, and I subtract 6, which is equal to 0, which is equal to 0, so it's good. Okay, down here at the bottom, sometimes one of the answers will not work, and we call this the extraneous solution or the extra solution, because it's just an extra solution that comes out, and it just so happens doesn't work. There's not one in this problem, and I believe there's not any more as the problems in this video go, but always, this is why we do this 5th step, just to make sure there aren't any extraneous solutions. Okay, now we're going to do an example that involves the leading coefficient not to be 1, and I'm going to tell you how to fix it. So we're going to make leading coefficient 1. Equal 1. And we do this by just taking this away and multiplying it to the end. So multiplying by 2, and I'm going to get rid of it over here. It's just the way we do things. So I'm going to x squared minus 9x plus 20 is equal to 0. Now I just solve this like I would any other. So it's going to be find the pair. So my constant is 20. So what two numbers multiplied are 20? I know 4 and 5 multiplied equal 20. But do 4 plus 5 equals 9, negative 9, and you always have to have that negative there when it's present? No, 9 does not equal negative 9. That people might make that mistake because they won't pick up this negative here, but you always have to catch that. So let's pick two numbers. My new numbers here will be negative 4 and negative 5. So when I multiply two negative numbers, it becomes a positive, and if you need negative man from Unit 1, if you want to go check them out, just to remember that rule. So 20 equals 20. And then let's see when I add them. So negative 4 plus negative 5 is equal to negative 9. So negative 9 is equal to negative 9. Good. So my pair, I found my pair. It's going to be negative 4 and negative 5. Now remember, in this step, yes, this is the example continued, but I'm going to erase this to save room. I make binomials with each x minus 4 and x minus 5. And I set each one equal to 0. So make binomials and solve for x. So this one's going to be, I add 4, those cancel. So I get x equals 4, and then x minus 5 is equal to 0, plus 5, x is equal to 5. Now, this is where the original leading term comes back in. So you divide each term you found by the original coefficient, leading coefficient. So I divide each one by 2, which was our leading coefficient, as you can tell from the 2x squared. So I get x equals 2 and x equals 5 over 2. These are our new numbers, and then we do the check step thing. So my original equation, 2x squared plus 9 minus 9x plus 10. First I'm going to plug in 2. So wherever there's an x, I plug in. It's equal to 0. So 2 squared is 4 times 2 is 8, minus 9 times 2, 18, plus 10. So that's going to be negative 10 plus 10 is equal to 0. So 0 is equal to 0. Good deal. And now let's solve it out with the 5 over 2. So 2 times 5 over 2 squared minus 9 times 5 over 2 squared, not squared, plus 10 is equal to 0. So 5 over 2 squared is 25 over 4 times 2 is 25 over 2 minus 9 times 5 over 2, which is 45 over 2, plus 10. And because I don't want to work with fractions, I'm going to multiply the entire thing by 2. So I got 25 minus 45 plus 10, 20, because I multiplied by 2, is equal to 0. That's negative 20. 20 minus 45 is negative 20, plus 20 is equal to 0, and I got 0 is equal to 0, and that's correct. So no extraneous solutions. They both work out. Our answers to the quadratic is 2 and 5 over 2. Okay. Now, if you're solving these out and you can't find a pair of numbers that multiply to equal the coefficient and add together to equal the second constant, you could do something called completing the square. So, the first thing that you're doing completing the square is to move the constant by eliminating it from this side of the equation through the opposite subtraction and doing it to this side. So I get x squared plus 6x equals negative 1. My next step is to take the second coefficient, divide it by 2, 6 divided by 2 is 3, 3 squared is 9, and then take that square number and add it to both sides. So I end up with x squared plus 6x plus 9 is equal to 8. Now, I rewrote my equation, and I'm going to rewrite this as a 8 to make my life easier. And now I take the square root of my new constant on this side, which is 9, and I rewrite it as a binomial. So 9, I rewrite it as a binomial, and I take the sign from here, so it's going to be positive, and I square it. So I end up with 3x squared equals 8. And now I'm just going to solve for x. To get rid of a square, we have to take the square root. And when we take the square root of this side, that's not a squared number. It has to be plus, we have to put this plus or minus sign. So I make two equations, one here, two here. One where it's the positive 8 square root of 8 and the negative square root of 8. And then I just solve for x like a normal algebraic equation by getting rid of the 3 on this side. So when subtracting the 3, I ended up with x equals negative 3 plus 2 to the square root of 2, and that's just the simplification of the square root of 8. That equals 2 to the square root of 2. And if you want to simplify radicals, you can go visit out some of my old videos, not my old videos, my previous videos on simplifying radicals. So I end up with x equals negative 3 plus 2 to the square root of 2. And I repeat the same process with the negative square root of 8. And I get x equals negative 3 minus 2 the square root of 2, which is the simplification of the square root of 8. Okay, now I'm going to walk you through one. So I've already exhausted my options, can't figure out how to find two pairs that multiply to equal 1 and add to equal the second term, like I would in the very first way we learned to do quadratics. So now, my first step is to move constant. So I do the opposite sign, so minus 3, minus 3. So I get x squared plus 6x is equal to negative 3. Then I take the second coefficient, divide it by 2, and I square that number. Then I add it to both sides. So plus 9 plus 9. And that equation becomes, I'm going to use a new color, x squared plus 6x plus 9 is equal to 6. So now, and then that second step was, I'm going to call it completing the square because I want to save time on writing this. And you can look at the exact steps in the previous slides by rewinding this video. So remember, I take this term, I take its square root, and I make a binomial like this. And then I just make a binomial keeping that first sign and the square root of that being that, and equals 6. And now I just solve for x like a normal equation. So solve for x. So I'm going to start with, I took the square root of both sides, so I end up with x plus 3 is equal to plus or minus the square root of 6. So I'm going to make two equations, 1, 2. I'm going to give it a little more space for that first equation, and I'm going to use a different color for the second one. X plus 3 is equal to, I'm going to do the positive square root of 6. So subtract 3 to both sides. I do the same thing down here. Eliminates that, and I get x equals square root of 6, negative the square root of 6 minus 3. And those are my answers. if I check those by plugging it back into the original equation. And you would probably have a calculator to do this one because of the radical. Okay, here's some practice problems. I want you to pause the video to work them out and unpause when you're ready. And hint for this one, use completing the square. I'm going to draw a square there. Get it? Completing the square? Ha ha ha. So pause the video now and unpause the video for the answers. Okay, so let me walk you through my answers. For number 1, I figured out the pair of numbers would be -5 and 3 because -5 times -3 is equal to 15, and -5 plus a -3 is equal to -8. So I made each one a binomial here, and I set it equals 0, and I solved it out, and ended up with x equals 5 and x equals 3. And when I plugged into the original equation, and I solved it all out, all my work is right here, I got 0 equals 0, 0 equals 0, so they both worked out a-okay. For the next one, my pair was 3 and 4, because 3 times 4 is 12, and 3 plus 4 is 7. So here, I made the two here, 1 and 2. I made the two binomials. I set them equals 0. I got x equals -3 and x equals -4, which, by the way, are going to end up being the answers because I plugged in -3 over here, and I plugged in -4 over here to the original equation. I worked it out. I got 0 equals 0 and 0 equals 0. They both checked out, so my two answers are x equals -3 and x equals -4. By the way, I don't know if I made it clear earlier, but the solutions of a quadratic are when it's equal to 0. So that's why I always get the 0 equals 0 thing. Okay. So this third one we had to use completing the square. So I start here. Walk you through it. I subtracted 7 from both sides, which eliminated it here. So I got x squared minus 6 equals -7. But these plus 9s come from when I divide the second number and I add it to both sides. I take the second number, I square it, and I add it to both sides. So it's plus 9 to both sides, so I end up with x squared minus 6x plus 9. Then I made it a binomial, x minus 3, because I took the sign from here, the negative, and I took the square root of this number, and I made it a binomial, x minus 3. I took the square root of both, and I ended up with x minus 3 equals plus or minus the square root of 2. So here I did the positive square root of 2. I added 3 to both sides to eliminate it. I got x equals the square root of 2 plus 3, and I did the same with the negative square root of 2. So x minus 3, I added the 3. I end up with x equals negative the square root of 2 plus 3. So those are the solutions. Okay, graphing quadratics. A quadratic resembles a parabola because, a parabola, because if you remember, x squared equals y. That's a quadratic because its highest power is 2. It's just not the standard ones we're working at. It looks like that, parabola. So I graphed this one, x squared plus x plus 1, and I ended up with this lovely curve. And the way you can graph these is just by making an input-output table. So this is my in, this is my out. So I plug in each input value to the equation, and I get an output value. I just graph that out. By the way, quadratics are always parabolas. Now, negative versus positive quadratics. A negative leading coefficient will result in a downward-facing parabola, while a positive leading coefficient will result in an upwards one. So I just use x squared as my example. So if I had negative x squared, it faces down. Think about it. When you get negative, like money, which means you owe money, you're frowning down, how it looks like a frown of a frowny face. And then when you have positive, when you're positive, you're smiling. So positive, smile, up. Okay, here are quick characteristics of a quadratic graph. The center is, the vertex is what we call the center. It's the center part of the dip here of the parabola. The axis of symmetry is a line drawn through the vertex so that if I were to flip each side over that line, it would look exactly the same because it's like the symmetry line between the two because parabolas are symmetrical. Okay, minimum or maximums. It's the highest or lowest point on a graph. In this example, we only have a minimum because the lines go forever in the positive direction, so there is no maximum. The maximum would be like infinity because there is none. And the minimum is 0 because that's the lowest point on the y-axis. You always look at the y-axis for this. It's the lowest point we ever reach on the y-axis. An example of having a maximum but not a minimum would be like this, a negative parabola, where this would be the max, and there'd be no minimum. In this one, we have a min, which is there, and no max. Okay, here's some practice. I want you to graph each quadratic by just making an input-output table. So pause the video now to solve it out, and unpause the video for the answers. Okay, so here's what I got. I just used 3 test points, -1, 0, and 1. Then I plugged -1 into x squared plus 2x plus 2, I got 1. When I plugged in 0, I got 2. When I plugged in 1, I got 5. So my graph looks like this. In my second one, I plugged in -0 and 1. When I plugged in -1 to -x squared plus x plus 3, I got 1. When I plugged in 0, I got 3. When I plugged in 1, I got 3. And that's how my graph looked like. Notice how we had a negative leading coefficient, so it's pointing downwards. Now I have x squared plus x minus 1. I plug in -1, 0, and 1. And I got -1, -1, and 1 respectively to that. And I graphed it, and that's what it looks like. Okay. Thank you so much for watching. I hope you learned something new today. Any questions or comments, leave them in the comment section below. My name is Maysie Calzone from Maysie's Algebra Initiative, signing off.